One of them is an E. So look on your calculator and see if you can find that E. It has an E to the X on it, actually. See if you see it. Anyone see it? It's above the key that says LN. It's next to the 4.
Yeah, it's 3 buttons or 2 buttons up, bottom left corner.
And if you access it, you're hitting the second button and then the LN key, and it'll have an E with a little box up there, and you have to put something in it. So if you want to know the value of E, if you put a 1 in that little box and then hit enter, it'll tell you the value. It's like pi. It's an irrational number that's like pi, 2.71828. And I want to give you some history on this one tonight. It's used for exponential functions. And for LN, it's the base. It's called a natural logarithm, and we're going to be doing it tonight. And you use natural logarithms in a lot of areas. This is like, we used to have a problem in this course, and I haven't run across it yet, but it used to be finding the time a person died. And it uses the natural logarithms and the value E, the base E, to find the time of death. So in forensics, you're going to use it. It also uses E for studying compound functions, compound interest. Anything that is growth or decay. So if you work for a city and the city wants to know what the population is going to be in 10 years, you use one of these functions for that. So there's a lot of basic usage for E. In fact, a man named Bernoulli, have you ever heard of Bernoulli's formula? Bernoulli discovered it in 1683 while studying interest. He was doing interest problems and he kept coming across this number. And so he discovered that in 1683, but it didn't get a name until Euler did it. And he named it E in 1727. So it was a long time after that that they actually put the letter E with that number, just like with pi. It was a while after they discovered 3.14 before they discovered that they could call it pi. So Euler did that, and I don't know if there's a connection between Euler and E or not, but could be he decided to call it that because of his name starts with an E. Ln is a natural logarithm. And at the base, little bitty E down there, it could be understood. It's understood E. And we're going to learn about bases tonight. And Napier did that. Napier is the one that did logs. And he did that in 1614. So even before they discovered the natural log for E, that was the base E, the Napier was working with logs in 1614. So there's some histories of those famous mathematicians there that they're the reason that we study this today. The Ln and the E are inverses of each other. And we're going to see that in the graph. One of them will go like this, and one of them will come down like this. This is the log, and this is the exponential. Could be e to the x, to the x, 7 to the x, anything. But the log and the exponentials are inverses of each other, and we're going to find that out tonight. If it says LOG, see if you can find the LOG key on your calculator. You see it? It's right above the LN key. And if you want the log of something, then it's going to have a parentheses and you put in a number there. Let's do 100. Let's see what happens there when we put in 100. We hit enter and it's going to give us 2. So log of 100 equals 2. And that's because the base on a log is 10. It's understood to be 10 unless it's written there some other number. So log with base of 10 really means 10 to the second power equals 100. And some people do this little circle thing. Some people say that a little base to the answer is the big log number. This is called a big log number. And I'll put names on these for you in just a minute when we do the logs and we have to convert them back and forth. But that's what that means. Log base 10 of 100 equals 2. That's what that says. Log base 10 of 100 equals 2, which means 10 to the second power equals 2 if I put it in exponential form. Okay. There is one formula you're going to need because this is an interest type situation. This is called a compounded or a compound interest formula. And it's A equals P times 1 plus R over N to the NT. And I'll put this formula on your assignment. It's in the lecture. And I'm going to put out a formula sheet that you can use, and it's on your formula sheet as well. The P stands for the principal. That's how much you start with. The R is the rate of interest. And the N is the number of times compounded. So if it was compounded quarterly, how many times would that be?
4.
Mm-hmm. If it was semi-annual, how many times would that be?
2. Twice. 2.
And if it was annual, it would be
1.
once. And those are the ones, this is the one you use the most often. It's usually compounded quarterly. The other thing that you have in your formula is T, which is the number of years. So those are ones you're going to use. So it's A equals P parentheses 1 plus R over N to the NT. In this section, we will be doing some shifts just like we did before. So I'm going to remind you of some of the old ones that we did. So that if we had f of x equals x minus 2 to the third. Somebody's not muted. Plus 4. Do you remember this within the parentheses? What kind of shift was that before when we did this before? If it was inside the parentheses. Anybody remember? What kind of shift?
Left or right?
This is left or right. And in this case, since it's -2 or -2, which one is it going to be?
It's going to shift to the right.
It's opposite of what you think. So it's going to shift to the right 2 units. What if it's outside? What does it do if it's outside?
Up and down.
Up and down. And this one is?
Up 4.
Up 4. What if I put a minus in the front of this thing? What does it do?
It frowns.
It does. Well, this is a cubic, so it's going to do more than frown. It's going to make it go the other way. It's going to make it go that way. So what is it doing?
Reflects it.
Uh-huh. It reflects across the,
X-axis.
that's good. Okay, now then, let's see if we can associate that with these new ones. If we have f of x equals 2 to the x minus 3. These are going to be exponentials, so our shifts are going to be up here in this exponent thing, part of them. And that's like having a parentheses when you have a little group up there as an exponent. It works the same way that it did when it was in the parentheses up here. So what would that one do?
It would shift
Go
to the right.
3.
Right, 3. What would f of x equals 3 to the x plus 4? What would that do? 3 is your x, is your base. X is your exponent. There's nothing added or subtracted, so there's no left or right shift. What does this one do?
Goes up
Because
4.
This one goes up 4. Let's make it a little harder. What if we had 5 minus 2 to the x plus 1? Look for your part of it that is the exponential. Your basic one in this case would be 2 to the x. Basic is 2 to the x, but then you've got this shift that's right here. You've got a shift that's right here, and you've got a shift because of the minus. So somebody tell me what this one inside is going to do.
it's going to shift to the left.
Shift left, 1 unit. What is the 5 going to do?
Up 5.
Up 5 units. And this minus in front of the 2, what is it going to do?
Left 2.
No,
Right 2. Right 2.
that's a reflection. The 2 is part of your equation that is your basic one. It's an exponential. Look up to, we did one tonight. This
Make
one
it
right here.
frame.
Reflects across the x-axis.
This reflects across the x. Okay, let's do one more that's more complicated and see if we can do it. What if we had f of x equals 4 to the 3 minus x minus 2? Now, I want to remind you, because some of you had trouble with the basic graph. The basic graph on this one would be y equals 4 to the x. This is your base, and this is the little x that would be up there, but we've messed with it. So we've got some things happening on it. Let's do the easy one first. Let's do this minus 2. What is that one going to do?
Down
Step
2.
Down 2.
This one's down 2. Let's take care of this up here. What is this positive 3 going to do?
Left 3.
It's going to be left 3. That's correct. Because it's opposite of what you think, and it's a little group, so it's left or right shift. In that case, it's left. Now we have it, the minus is not in front of the 4 here. The minus is right here in front of the x inside the parentheses. What does that one do? We've only done one of those, and it was on the final, the very first one on the final. Does anybody remember what that minus in front of that x that's in the parentheses does?
Does it reflect across the y-axis?
That's it. Reflect across the y-axis. That's right. If the minus had been in front of this 4, it would have reflected across the x-axis. But because it's in that parentheses and it's in front of that x, it's across the y-axis. And you're going to run into that tonight in the homework. Okay, any questions about all of that information that we're going to need for our first section? These are all college algebra. We don't have any support assignments tonight for these two sections. It's all college algebra. So let's look at them. This is section 9.3 that we'll be doing. And number 1, it says use a calculator. Okay, to approximate the exponential expression to 4 decimal places. And they want you to find e to the second. And these little squiggly lines means approximately equal to. So take your calculator, find e, and put in a 2 there. Somebody tell me what you get to 4 decimal places. You'll have to hit your second key and then the ln key. And then when it gives you e there, you'll have to put the 2 in and then hit enter. Somebody tell me what it is to 4 decimal places.
7.389.
Okay, let's discuss it. 7.38, and then it was 9056099 or something like that. There's the 4th place right there. So what will it be since this is a 5 after it?
1.
It's got to go up to a 1 there. Okay. Number 2 is the same thing, but they want to the nearest 10 thousandths. Nearest 10 thousandth. So we have e to the negative 3.43. Put it in your calculator and see if you can get it. Chandra, I see you're here. Do you have the answer to that?
Yes.
What'd you get?
1, 2, 3, 4. 0, 3, 2, 4.
Okay, did everybody get it? If you put in the wrong decimal there on the end, it will not count it for you. Okay, now then we're going to graph these. Let's graph, and these will be multiple choice. By the way, on those multiple choice questions that were on the test, if you counted the wrong multiple choice, there wasn't much I could do about that. So let's see how these look. Go to y equals, oh, not second plot, y equals. And you clear out that was in there, and you do 5, and you use your caret key and put in an x in there. And that's 5 to the x power, and it's going to be an exponential. And when you graph it, it's going to look like that. All of these exponential functions look like that unless they have a shift on them. It's going to go through the point 0, 1, and that's because if you put a 0 in for x, what is 5 to the 0 power?
Is it 1?
So if you use your table and you go to table, and
Can you show again where you get the 5 to the x? I can't
sure
find the
will.
key.
y equals,
Sorry.
that's okay. Put in the 5, I'll just take it back out. Put in the 5,
Okay.
and then you can do
Okay.
a caret, do the caret that's above the divided by sign
Caret. Okay. I was looking for the key. I was like, am I going crazy?
to the x. Oh, I'm sure there is
Okay.
one under math. So all of these are going to go
Okay, I
through the point 0, 1, unless there's a shift on them. They're all going to go through that. Now, once you start adding shifts to them, it'll shift. And this is, you know, like we did on the vertex when we had those parabolas and we were shifting them. We used our vertex as kind of our basic point that we used to shift. This will be your basic point that you use to shift these around. So it's that 0, 1 point that's real common to every one of these basic equations. And if you add or subtract something to this x or add or subtracted something to here, it'll be this focal point that you move up or down that will change your graph. If you want some other points that are in it, you will look for some really easy points like -1.2, -2.04, 1.5, 225 is off the scale. So what happens is it goes up really fast. Now, can you tell me something that we've had recently in our last year of our lives that took the form of an exponential function?
COVID, yes.
COVID. COVID was, I did the chart on it when we had the algebra class last year. And we did the chart on it to show how fast it was going up. And it took the form of an exponential function for the first, probably 3 months before it took off and went in a different direction because it was going up so quickly. And so that's one of our practical applications that we've had in the last year was COVID took it on an exponential function. All right, let's do number 4. Number 4 is y is equal to 4 to the x. See if you can do it. Y is equal to 4 to the x. You're not going to be able to see much difference between 5 to the x and 4 to the x. Did you get it? Did you get the picture? The only difference is 5 goes up a little steeper than 4 will, but they both go through the point 0, 1. The other graphs that you'll be looking at will look something like this. And what's this one? This one goes this way. And there's one that goes this way. So they're real different than the one that you have there. So it won't be hard for you to decide which one is the correct graph if you put it in your calculator correctly. Let's see what happens when we have a fraction for our base. What do you think is going to happen to our picture when our base becomes not 4 and not 5, but a fraction? Put it in parentheses and raise it to the x power and see what you get. What does it do that's different?
Comes from the top.
It comes from the top down. It still goes through the 0, 1 point, but it's going to come this way. And the reason it's so steep is because that's a 6. It's even steeper than the 5 was. But the fractions will come this way, whereas the whole numbers go up this way. Okay, let's look at number 6. And these are all multiple choice. Number 6 is y equals 5/8. And this one says e to the x. 5/8 times e to the x. So this one is a very different one than the ones we've had. It's added on this e. So how do you put that one in your calculator? Anyone know?
Yeah, you put in parentheses 5/8, close parentheses, e to the x power.
That's it. You'll have to figure out how to get it in there. You'll have to put your second and your ln key will get you your e, and then you put that little x right there in that exponent place, and let's see what it looks like. Notice that if you look at that one, it's not going through the 0, 1 any longer. Why not? It says at 0, I have 0.625. Why does that happen?
Because the e makes it turn into a decimal.
No, the e, if I just had e to the x, it would go through 0, 1, because if I put a 0 in here for x, e to the 0 power is going to be 1. But because you're multiplying it by 5/8, 5/8 is 0.625. That's why it ends up going through 0.625, because this would be 1 times 0.625. All right. They all pretty much look the same. When you get to number 7, you're going to start the shifts. It says f of x equals 2 to the x minus 2. And it says write the basic graph. So what would our basic graph be?
2 to the x power.
And the y equals is out here. You don't put it in. You're just putting in 2 to the x. Then you write the shift. What will this one do?
Right, 2.
Right 2. Now you can put this, let's look at it on the table and see what this looks like when we put it in to graph it. And there is a multiple choice graph for you to choose from. It's 2, and you use your caret, but this time in that little box up there, you've got to write x minus 2 and make sure all of it's in your exponent. So this is going to shift. And what it's doing is shifting. Remember, it used to be at 0, 1. Now it's going to shift over 2. So now it's at 2, 1. That's where your point is. The graph has shifted 2 to the right. Okay. Am I going too fast? Are you staying up with me?
Stand up.
Okay. Let's look at number 8. Number 8, you have f of x equals 5 to the x plus 3. And they want the basic. What is the basic graph? And it says y equals, and you put it in the blank.
Five to the x power.
And then there's a shift. What is the shift going to do?
Left 3 units.
It's up 3. And gosh, we can almost do it at this point. Instead of it going to 0, 1, it's going to go through 0, 3. It's going to shift up 3. If you can't do it,
Now it's shifting up 3 because it's not in parentheses, right?
right, it's not up here with this little x. It's over here on the outside of it.
Would it shift up from 0, 1, 3 or from 0, 0,
Now,
3?
the normal graph, the 5 to the x would go right through here at the 0, 1. But remember, I told you that's your focal point you want to shift. You're going to shift it up to 3.
Up
Well,
2.
up to 3, good. That's just 2, isn't it? Who said that?
Amanda.
Should shift it up 3, shouldn't I? Who did that?
Amanda.
Okay. Give you a point, Missy. Now, I would have caught it if I had actually put it in my calculator like I'm supposed to. Now, when you put that 5 to the x in there, if you don't hit the arrow over here to bring that cursor back down, it'll put that 3 in there as an exponent. So you have to hit this arrow to bring that cursor back down to put that +3. So be sure that you do that, or it'll put that 3 up there as an exponent. It'll make it a shift to the left instead of up. Okay, now let's check our points out here. Second in table. See, I would have caught it because see at 0, what does it say?
4.
Says 4, and that would be a shift of 3 up from the 0, 1 spot. Good deal. Okay. All right, they're going to give us, it's the same kind of problem. We just have to describe the shifts. And then we have to graph it. This one's going to be hard to graph because it's going to shift it several ways. We'll probably be better off getting some points off of our graph for this one. What does this +3 do?
Go up 3.
Up 3. What does this 2 that's inside here do?
Left.
This is left. Remember, it's the opposite of what you think, and that's a positive too, so you shift it left. Now, this is one of those new ones. What does that minus in front of that x do?
Reflects across Y.
Reflect across the y-axis. And let's graph this one. This one's probably easier to do when you plot it from, and you're not actually plotting them, you're picking a multiple choice for it. Actually, they may, I don't have this written that these are multiple choice, so you may actually have to plot these. Has anyone done this assignment to remember if it's, I think you have to actually plot these in this group. So I put it in the 2 minus x and then the +3. And look how it's going. It's going to go from here down because my reflection's across that y, not across the x. So let's pick out some points that's easy to plot this. -467 is not a good point to plot. But -111 I could probably do. 0.7 I could probably do. 1.5 and 2.4 are not bad ones. -111's way up there. 0.7. 1.5 and 2.4 gives me an idea of how that comes in. And if you have to plot this, you'll have to use, I wish I'd looked this up. You'll have to use the little key that looks like exponential. It'll be an exponential curve. And at the bottom, remember when we did these before where you had to put in these shifts? It'll say shift left and then you'll put the number of units, shift up, and you'll put the number of units, and then it'll say reflect, and you'll say across the Y. So you may have some issues trying to graph those until you get used to them. And I don't remember how many dots it takes, probably 3. Somebody go on there while we're doing it, Luke or Chandra or somebody, Eric, go on the site under number 9 and see if it, for 9.3, and see if it gives you the tool to graph it, and if it has these options here for you to have to fill in. Somebody do that for me and let me know.
9.3.
Number 9, go down to 9.
9. Okay, it gives you, here's the example. Mine's f of x equals 3, 1 minus x plus 3, and it uses the special graphing tool. 3, 1 minus x plus 3. And then describe how the graph can be obtained from the graph of the basic exponential function of 3x, and sketch the graph of the following function. And
Okay.
it starts with that special graphing tool.
And it starts with a special graphing tool. Does it look like a little exponential graphing tool?
Yes, it gives you the option of logarithmic, exponential, your vertical, horizontal shifts.
Okay.
So it's not just graphing points, it's using a special tool. So you got to be spot on when you shift.
Okay,
and
so
reflect.
this is your exponential one, the one that goes up, and it looks something like this.
Correct.
And the logarithmic one is going to look like this. Okay. They're inverses of each other. So ours are all in this section going to be exponential. So you're going to pick this tool, and then you'll have to go down there. What are your choices on shifts left?
3 choices. One is shift the graph of y equals 3x left 1, reflected across the y-axis and shifted up 3 units. B, shift the graph of y of 3x left 1 unit, reflected across the y-axis and shift it down 3 units. Or C, shift the graph of y 3x left 1 unit and reflected across the x-axis and shift it up 3 units.
Okay, so which one do you think we want?
We're gonna shift it left 1 time.
Okay, shift left
Then
once.
Then since it's x, we're going to reflect it across the y-axis, and we're going to shift it up 3 units.
And that was A, wasn't it? It was that first choice.
Yes, A.
Okay. All right. And then you'll have to pick a tool. If you're in the exponential ones, you'll pick this tool. If you're in logarithmic ones, you'll pick this tool. And we'll do the logs in a little bit. Okay. Thank you. All right. Let's look at number 10. Number 10 is the same kind of thing. It's 3 minus 2 to the negative x. So the basic, what is our basic graph?
Is it 2 to the x?
Mm-hmm. You're good at that, aren't you? Y equals 2 to the x. So then we've got to figure out this and this and this. What does the 3 do?
Shifts to the left.
Mm-mm.
No, the 3. I'm sorry. Up
Up.
3.
Up 3. What does the minus in front of the 2 do?
Shift down.
No.
Oh, I'm thinking about the exponent. I'm sorry.
Reflects across the X.
Reflect across the x. That's this one.
Okay.
Now, what does this minus up here do? What does this one on the exponent do?
Reflects the y.
Yes. Okay, now see if you can put it in your calculator and see what this graph looks like. And we'll get some points off of our t-chart, off of our table. 3 minus 2, raise it to the negative, and use the negative down by enter, not that connector negative, negative x. If you use the minus 1, you'll get an error. So use this minus down here for that little negative in front of that x, little x. Okay, so when we graph it, that's interesting. Almost looks like a logarithmic one, and it's because it's reflected across that x-axis. Now let's do the table and pick out some values that we can use. -3, -5 is okay. -2, -1, -1, 1, 0, 2, 1, 2.5, and so on. There's asymptote coming up there. -3, -5, -2, -1, -1, -1, no, -1, 1, 0, 2, and then it starts getting really skinny. So it looks like that. Okay, let's try number 11. Number 11 is f of x equals 2 to the x plus 5 minus 4. All right, what is the basic graph?
Two to the x.
Uh-huh. Okay, what is this plus 5 going to do?
Left 5.
And what is this minus 4 going to do?
Down 4.
Yep. And let's see, what is this graph going to look like? Are you getting good at putting these in there now?
Mm-hmm.
-6 is -3.5, -5 is -3, -4 is -2, -3 is 0, -2 is 4, -1 is 12. So -1, 2, 1, 2, 3, 4, 5, 6, 3.5, 3, 2, -3 is 0, and then it starts going up really fast. So it looks like that. Any questions on that? I think we've got that down. Okay, let's do a word problem using our little handy dandy formula that I told you about in the lecture. It says, suppose that $68,000 is invested at 5.5% interest, compounded quarterly A. Find the function after t years. That means you're just going to leave the t in there. So we're using A equals P 1 plus R over N to the NT. When you start doing these, they're going to ask you 3 or 4 things on the same one. So just leave your formula in there and I'll tell you how you can do that. We're going to do 0 years, 4 years, 8 years, and 10 years. All right. So we got to figure out what values go in there. What do you think the P is? Remember, the P was the principal.
68,000.
68,000. So right here, we're going to put 68,000. The 1 is part of our formula. What is our R?
The rate, which is 5 points.
How are we going to do that in a decimal form, that 5.5%? What will that be as a decimal?
0.055.
0.055. You move the decimal point 2 places, and that 1/2 is a 5. Hundredths. The percent means 100ths. Okay, the N is number of times of year that it's compounded. So what would it be since it says quarterly?
4.
So N is equal to 4. And then up here you have 4 times T. So this is your formula that they want for the A, except that I think they go ahead and figure out what this is. So somebody in your calculator do 1 plus 0.055 divided by 4, and let's see what that amount is. You got
1.01375.
0.01375. That one. And this is going to be 4T up here. So that's what they want for the first part of the problem, this right here. That's your formula with T in there. Now then, put that in your calculator in a blank screen. Put 68,000 parentheses 1.01375, close your parentheses, and raise it to whatever we're going to do here. 0 years would be 0 times 4, which is what?
0.
0. So put a 0 in there and then hit enter and see what you get. What do you get?
68,000.
Doesn't that make sense that it would be 68,000? Because this to the 0 power would be 1, and 1 times 68,000 would be 68,000. Okay, now then, don't reprint it, don't retype it in there. Hit the second button and the enter button, and it will reprint what you've done there, the 68,000 times the number. And then just go backwards and change that 0 to whatever you want it to be. In the second one, I want to do 4 years. So it's 4 times 4, which would be what?
16.
16. So put a 16 in there and hit enter. And what did you get?
$84,606.
Okay.
Mhm.
Now then do the same thing. Do second and the enter key. We'll put that back in there. And then this time we want to change it to what? We want to do 8. So 4 times 8 would be
32.
32. Has anyone done it? What do you get?
105, 268.
105, 268. Okay, and then for 10 years, it's going to be 10 times 4, which is 40. So your answer is 117420. Any questions on how those are done?
This is something I can get down with because I have to calculate our owner's interest every month at month end.
Oh, so you can do this already. That's great. Okay.
Dr. Sullivan, how did we get the 0.055?
Oh, okay. This 5.5%, we'll write it down here. 5.5% is really 5.5 because 1/2 equals 0.5. So 5.5%. Then to change it from a percent to a decimal, because you can't leave your percent in there, you have to add a 0 in front of this to be able to add to move your decimal point 2 places to the left. So that's how I get 0.055 to change from a percent to a decimal. This is the decimal, that's the percent. So the 1/2 became this 5. This 5 was that 5. Then I moved the decimal point 2 places to the left, so I got 0.055. Is that good?
Yes.
Okay. Anybody don't understand the quarterly? It's 4 times a year. Sometimes it'll say semi-annually will be a 2, or it might say annually.
How do we put that parentheses 1 plus 0.055 over 4 in our calculators?
Do what now? Say that.
The A equals 6,800 with the parentheses stuff that's right there. Every time I put that in, it's giving me a way different number. So how are you putting that in the calculator?
This one right here.
Yeah, no,
Okay.
above that.
Which one? This one?
Yes.
I don't put that one in there. I changed this to this number right here. I did 1 plus, you see that 1 plus, and then I
Yes.
did 0.055 divided by 4, and you get 1.01375.
Okay, I got it. I was trying to put the 68,000 in with it. I got it. Thanks.
Okay. Any other questions? Those are good questions. Okay. Let's do the last one. There's not very many of these. Let's do the last one, and then we're going to do our poll for tonight and check our attendance again, and then we'll do 9.4. This is Melissa, and she's having a birthday. Melissa's 6th birthday. She gets a $4,000 CD. Boy, I'd like to have that. And it earns 3% interest compounded. I don't know where she's going to get this, that it compounds quarterly. If the CD matures on her 13th birthday, how much money will be available? Nearest cent. It says round to the nearest cent. All right. I'll try to go slower because I know some of you are trying to write that down that didn't have it already printed off. Okay. What is our P?
4,000.
4,000. Because that's how much it was to start with. 1 plus, I need the R. What's the R? What is, and how do I write 3% as a decimal?
0.03.
0.03. And how many times per year is it going to compound?
4.
4. And then I have a 4 times, and I got to figure out my time here. She got it on her 6th birthday, and it matured on her 13th birthday. What is our T?
7.
7. So T equals 7. So then I guess we can just put this in our calculator just like this. I'm going to put 28 up here instead of 4 times 7 in case I mess up somewhere here. See if I can put it in here just like this. 4,000 parentheses 1 plus 0.03 divided by 4 close parentheses. Raise that to 28 because 4 times 7 is 28. Okay, everybody okay with that?
Mm-hmm.
I'm going to hit enter. What do I get? $4,930.85. Because that was a 4 and there was a 6 after it, so I raised it to 85. Got it?
Mm-hmm.
See, those aren't so bad. And there's not many of them. There's not like 100 of them like sometimes we run into.
Well, notice the easy problems, they will give you a lot of.
Yeah. We'll have some in the next section because they are easy. All right, let's do a poll for tonight. Let's see if I can count the rest of the people here that haven't left me. A few people have already left, I see. Let's do the poll question. Gotta find it here. No, I don't want to edit. I want to find it. Okay. Let's see if you know the answer to this. If you were listening tonight, which of the mathematicians first used E to represent 2.71828? Let's see who's here that I haven't counted yet. Portia. Hi, Portia. I didn't say hi to you tonight.
Hello,
How are you doing tonight?
I'm okay. How are you?
I'm doing good. I don't think I counted Kiana here either. Hi, Kiana. Did Selena come in? I don't see Selena on here anywhere. Margaret's here, I see. Hi, Margaret.
Hi.
Astanika, did Astanika come? Astanika's always here. Where is she? Sequela. Donovan, did Donovan?
I'm here.
Who was that said they were here?
Shaquila.
Oh, hi, Shaquila. Donovan's here. I see Donovan's here. Tamala, did Tamala come in? I got Natalie. I don't see Tamala on here. Tamala's over here too. Okay. All right, looks like I'm still missing Selena and Tamala and Astanika, and she's always here. I'll have to call and find out where Astanika is. Daniel Westbrook. Is Daniel here? Daniel? Okay. All right, so let me end this and share the information. And 50% of you were right. It was Euler. You pronounce his name Euler like a O-I-L-E-R, even though it's spelled with an E. He's the one that first used it to represent the number. Bernoulli actually figured out that it was 2.1718, but he didn't name it. Euler named it. Okay, any
See,
questions?
I knew that. I knew that. I don't know why. I just
Well, you don't get counted right or wrong on this. It's just for attendance purposes anyway. All right, so let's do 9.4. And it's going to be, what do you think it's going to be on?
Logarithmic.
Logarithms. Yeah, this is logarithmic ones. So we'll learn how to put these in our calculator and do them. So this is 9.4. And these are all going to be logs. So if you have y equals log base 2 of x, this y is the answer, and it's the exponent of the exponential form. So logs are really exponents. That's all they are. Logarithms equal to exponent. This is an exponent in the exponential form. This 2 is called the base. And this is called the log number. Sometimes we call it the big log number because it's written big as opposed to this base, which is written small. So sometimes we call it the big log number, and it can never be negative. So you're going to run into some that you're going to have a negative log number there, and the answer doesn't exist. By the way, on the test, do you guys remember on the test what this means?
no solution.
No solution. Empty set. No solution. Do you know that I had 4 people that wrote this instead, and they did not count it, and I couldn't give you credit? What is this? What is this right here?
An answer.
It's an answer. It's 0. Okay? So if you didn't put this with a slash through it, I couldn't count it because it has to have that slash through it for it to be empty set. If you just put this without that slash through it, I couldn't count it for you. And there were 4 people at least that did that. Just reminded me when I did this. Okay. Let's go to the other form. The other form is 2 to the y equals the x. Again, this is the base. The 2 is the base. The y is the answer for log form. And the 2 is, the x is the big log number. So you're going to have to convert these from one form to the other. This is the log form. This is the exponential form. Okay? So we're going to convert them back and forth. Now, your calculator does way too much work for you. It has a log function. And we're going to learn to do these on your calculator and learn to do them by hand too. It's under math. And you go down, way down to A. It's almost to the end of the list, and you're finding log, and it has capital B-A-S-E with a parentheses. So see if you can find that on your calculator. You go to math, and you go down, 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 until it says log. See that L-O-G, base, parentheses? You see that? You're going to be able to use that for these problems. Before we get into the problems, that will let you put in the base and the log number so you can do any base, which is okay. There are some things that you're going to need to know while you're doing this section. There is a change of base formula, because it's going to ask you to use this. If you have log base 6 of 36, let's say that, you can write it as log 36 over log 6. Log 36 over log 6. And what it does is changes that to base 10. If it's not written a base there, it's understood to be base 10. And your calculator is based on base 10. So let's see what this number would be. Let's do log, L-O-G, 36. Don't forget to close your parentheses. Divided by log 6. Close your parentheses. And let's see what we get. What'd you get? Two. All right. So that's called the change of base formula. It's log over the log number over log of the base. And what you're doing is change it from base 6.
I got a question.
Yeah, I didn't get that, but I put it in.
Yeah, I didn't get the way you put it in.
Okay. Let's do it again.
Did you put the log 36 over log 6? Okay.
Yeah. Log 36. Now, if you don't close that parentheses, it'll think it's still open. So see how it opened the parentheses on the 36? You have to close that parentheses on that 36.
Okay, yeah.
Now then do divided by, because that's what that line over that means.
I can't really see it clearly. You put the 36 inside the parentheses?
Yes. 36 is in parentheses and 6 is in parentheses.
Okay.
And you should get 2. Okay. Did you get it that time?
Yes, I did.
Okay. All right. That's called the change of base formula. There's another one that you're going to need, and this is the equation form. So if you have log 6 of 36, you put it equal to x and solve it as an equation. So you have log 6, 36 equals x. And you're going to use this exponential thing. You're going to change it from log base 2 of x to 2 to the y equals x. In this case, people do this. They do 6 to the x equals 36. That might help you remember. I don't know. But you can change it to the exponential form by doing base to the answer equals the big log number. Base to the answer is the big log number. You're going to have to change these from log form to exponential form and exponential form to log form. And it's a good thing to keep in mind that this little number here is the base, and it becomes in that position when you change it to exponential. So my base is 6. So your goal is to try to get the bases the same base on each side. Okay, so my base is 6 and I have an exponent of x. Is there any way I can change 36 to a base of 6? Is 6 to the something 36?
Squared.
6 squared is 36. So now once you get the bases the same, you can cancel off the bases and set your exponents equal, and you get your answer. And we knew it was 2 because we did it on our calculator earlier. Okay, so that's what we need to know to work these problems. They're going to give us plenty of practice. Anyone need this anymore? Are we through?
I'm still writing.
Okay.
Okay, thank you.
You're welcome. All right, let's see what kind of problems they're going to give us. Number 1, it says graph. And they give us y equals log base 2 of x. So we're going to learn to use that math key down to a and use log base and then parentheses. But first, we have to get to our y equals. So hit the y equal first. I'm going to take the one out that's in there. And once I get my y equals open, then I'm going to go down to the math thing. Math. Go all the way down until I get to the one that says log base. And I'm going to hit enter. And when I do, it's going to put log. And it's going to put a little box down here. And it's going to put a parentheses with a box here. Do you see that? All right. So that means we're going to put in 2 in this little box. And in that big box, we're going to put x. 2 in the little box. And in the big box, we're going to put x. Everybody okay with that?
Yes.
All right, now they want us to graph it. So we're going to graph it and see what the picture looks like. And see, it's the one that goes sideways, and it's going to go through 1, 0. It's going to come down here and do this and go out this way. And if you want the points off of it, you can get it off the table. And see how it says error on those negative sides? That's because there's an asymptote at the y-axis, and there's not going to be any values for that graph over here on this side. Okay, now, did everybody get it using it that way? Anybody not be able to get the math and go down to A and use the log base? Looks like this. Is anybody that couldn't do that? We'll do another one that way. Okay, let's do it the same way, except this time we're going to use the change of base and do log x over log 2. So take that one out. And this time we're going to do the same problem, but we're using the change of base rule. And your LOG's on the keyboard on your calculator. So do log x, make sure you close the parentheses on that log x, divided by log 2. And you can put it directly in there just like that and not have to mess with the keys down to math. But you need to be able to do both because sometimes it's harder to use one or the other. Did you get the same picture? Yes?
Yes, ma'am.
Okay. So 2 ways to do it. You could use the math and the log base, putting it in just like this, 2 and the x, or you can do change of base, log x divided by log 2, and it'll get you the same picture. Okay, let's look at number 2. Number 2 says graph, and these are multiple choice graphs. F of x equals log x. Well, this one's so easy, you don't mess with that, the base one. I would just do y equals, clear out the other one, put log, and then put x and close your parentheses. See what it's doing? It's still going through there, but it's a real skinny graph. Still going through the 0, 1 point. Okay, let's try number 3. Number 3 uses a new logarithm. It's the ln x. Let's see what it looks like. Let's compare it. So this time we're going to hit y equals, clear out. Instead of doing log, we're going to go one down and do ln and put the x in there. And let's see what it looks like. It looks the same way. Same picture just about.
What did you enter in your calculator for the line equals x? What?
For the ln, it's ln. I use the ln key that's next to the 4, the number 4. You see the ln key right there? ln.
Oh, okay.
And I put an x there. And then I graphed it. That's a natural log. It's ln. A lot of people think it's in. I get students all the time that say in, but that's an L. ln.
Do you know
I don't see that.
Yeah, do you know how to return it to its regular view when you graph it?
Do
You
what?
can do that clear your RAM thing because my calculator was acting funny too.
How do you do that?
You go to the normal screen, like when you first turn it on, and press second plus 712, and it clears it out.
Second.
Or excuse me, second plus 712.
That clears. Did you get it?
Second plus 7, 1. What?
That clears your calculator where it should fix it to where to work right.
Second plus 7, 1, 2. Oh, okay, cool. Appreciate it.
Did you get it? Okay. Did it turn out okay then? The ln key is right there. ln. Then you hit the X. And then you graph it. It should look like that. Everybody good? All right, let's do number 4. It says find the logarithm. This is going to be a number. You can use we're going to figure out a couple of ways to do it. We've already done this one before, but we're going to do it again. Let's do it using our little handy dandy math key. Under math, go down to your A, log base, and it's on a blank screen. It's not in the y equals because we're wanting a number, not a graph. So see how you can put the 6 in for your base, and then come over here and put a 36 in for your big log number, and hit enter, and your answer's 2.
Okay, how do we get that 6 at the bottom again?
Okay, go to math and go all the way down to after 9, after 10, after 10 is an A, and it says log base. Do you see it there?
Yes, ma'am.
Okay, hit that, enter it, just put an enter, and it'll put it on your blank screen with a cursor that's cursing, it's blinking on the little 6, the little one, the base number. So you put in a 6 there. And then you have to use your arrow over to make it blink on the big square. And then you put your 36 in there, and then you hit enter and it'll give you the 2. Did you get it?
Yes, ma'am. Thank you.
Okay. The other way you can do it is you can say log 36 divided by log 6. So let's see if we can do it that way. You don't have to go to any kind of menu. You just hit the LOG key, log 36 divided by log 6. And that gives you the 2. Everybody get it that way? And the other way you can do it is to put an X in here and change this to exponential. 6 to the X equals 36, which is 6 to the X equals 6 to the second, which is X equals 2. And you're going to say, well, I'm not going to learn to do it that way if I could do it all the way on my calculator. Well, we're going to run into some problems by the end of this chapter that's not going to let you do it on the calculator. So you're going to have to use this method. So I want you to practice doing this with the easy ones before we get to ones where we have to change them to equations that are harder. So you can do it by using the math and doing it that way. You can do it by change a base, log 36 over log 6, or you can do it by changing it to an exponential. 3 ways to do the same problem. Every time the answer should be 2. Okay, let's do number 5. Number 5, log base 6 of 1296. All right, so pick away. Chandra, I want you to do it by change a base. Eric, are you still on?
Yeah.
Eric, do it by exponential. Change it to an exponential form. And Lori, do it by using the math and going down to A and putting it in the math.
Put it in the what? Exponential form like how?
Well, you have to
Like
put
1296 equals 6x?
Uh-huh.
Oh, my bad. Sorry.
Now 1296 must be something.
I went too quick, sorry.
Okay.
I thought we were yeah. My bad.
This is the exponential way. Change a base is log 1296 over log 6. And math way is log 6 1296. Okay. Chandra, what'd you get?
I got 2.42.
Which way did you do it?
I'm sorry, I did it change of base.
You did change your base. Okay. What'd you get?
I did the log, well, and it does the parentheses. Oh, I know what I did. I messed up.
Did you forget to put the end on your parentheses?
No, I forgot to put the divide like a doofus.
Oh, you put
So
multiply,
I'm
it's
doing
gonna be a different number.
log 1296, close parentheses, divided by log 6, close parentheses, enter 4.
She got 4. Okay. Did it? Who was doing this one? Lori?
I got 4.
Uh-huh. And Eric?
Or,
Mhm. Okay, everybody good on that? Pick a way. In fact, try to do it all 3 ways and make sure you can do it all 3 ways. Number 6. Log base 10, 0.001. Okay, this one's tough to do exponentially. Let's do change of base would be log 0.001 divided by log 10. Erica, can you do that one? Amanda, are you still on?
Yes, ma'am.
See if you can do 10 to the x equals 0.001 and figure that one out. And the other one is log base 10 of 0.001 using the math form. Marlisha, can you do that one?
Yes, ma'am.
Let's see, who did I assign a change of base to? Amanda, can you do a change of base?
Yes, ma'am. You have me doing the exponential.
Exponential?
Oh,
Yeah.
you have Erica. Sorry, I heard Amanda. I'll do the change of base. I got -3.
Okay. You did a change of base? -3. So the others ought to be -3. Let's figure out how we can get them. Who did this one down here?
Marlisha, I have -3 as well.
Okay. And you did the math?
Yes, ma'am.
Okay. Now, how are we going to do that on this one? Erica, you figured it out yet?
Not quite.
Okay. This one's kind of important to know how to do because we are going to run into a problem a little bit later that will help. We will need to know this information. This is 1/1000, isn't it? Isn't this in tenths, hundredths, thousandths? So this would be 1/1000th, right?
Yes.
So that would mean that's 10 to the x is 1/10 to the 3rd. Do you remember the rule on exponents? If I bring an exponent from the bottom of a fraction to the top, what is that rule? Does anybody remember that? That would be 10 to the -3. If I bring this to the top, it becomes a negative exponent. If I change it either from the top to the bottom or bottom to top, it changes the sign on the exponent. Now, once the bases are the same, you can set your exponent equal. Erica, I just stole your steam. Did you get it?
I'm still like processing it, but
Now, that one's hard, but it's important for you to be able to do that. We're going to do some more of those. And you have to do it that way. You can't do it with the logs. So 1/1000 is 0.001. And 1000 is 10 to the 3rd. And then if you want to move that to the top so that your bases are both big bases and not a 10 on the bottom, then that becomes 10 to the -3, which means your x is -3 when you set you cancel out your bases.
how did you get 1/1000? I'm sorry.
This is tenths, hundredths, thousandths. So this would be 1/1000th, which looks like this. Changing it from a decimal to a fraction would be 1/1000. That's what that means, that decimal. In fact, I think you can do it on your calculator. Your calculator might do it for you. Let's see, 0.001. If you go to math and go to that fraction key right there, it'll change it to 1/1000 for you. Okay, we'll do some more of those. So don't, at least you can do it this way and this way for this section for sure. All right, let's do number 7. Number 7 is log base 5 of 1/25. 3 ways. Let's do change of base. Let's do the math one, and let's do the exponential one. Okay, let's see. Who have I not picked on? Sequoia, you want to do one of those?
Sure.
Okay. Which one do you want to
Can
do?
I do the change of base?
Change of base?
I
Okay.
do change of base.
Okay. And Morgan, which one do you want to do?
I'll do math.
Okay. And that means Corey, can you do the exponential one? That's going to be a 5 to the x equals 1/25, and it works similarly to the one that we just did. You'll have to put that 1/25 in a parentheses on the top for sure.
Okay.
Okay, Morgan, did you get your answer yet?
-2.
-2. Okay. Sequoia, did you get it?
Every time I get it in, one of my kids asks me a question. Move, please. Move. Sorry.
It's okay. Corey? Did you get it?
Got -2.
Yes, that's correct. Did you get it?
Took me a second to get it in, but I got it.
Okay.
Yeah, I got it in there.
How did you get that one? Because when I did that one, I keep getting -0.5.
I used the log key, and then I put 1/25. I put 1 divided by 25, close parentheses, and then divided by log key again, 5, and close parentheses, and then enter.
Thank you.
Why is
Well,
that?
look, I didn't get it. And you know what happened? I put a double parentheses right here. And so it counted the last half of it and not the first. It took the log of whatever that number was there. So you have to be careful on that. The parentheses already starts for you. So don't put another parentheses or you'll make an error like I did.
Where did the 52 come from?
52. What 52? Oh, 5 squared. That's 25. 25 equals 5 squared.
Okay, because I was like, what? Okay, I didn't want to mess it up. Okay.
But it's in the bottom. How did we get it in the top a while ago?
Make it negative.
Mm-hmm. Now then, they're both big 5, so I have x equals -2. Corey, did you get it?
Okay, before we weren't putting the division sign in between the two logs. Did we do that because it's a fraction?
Anytime you use a change of base, there's a division sign between the two logs.
I wasn't using that for the last ones, and I was able to
Are
get the
you
correct
sure?
answer.
You had to be, or you'd have a different number.
Okay, yes, I did. I see it now that I was using it. Okay. Thank you.
Corey, did you get this -2 on yours? Corey Castillo. Yes, sir.
Yeah, I got it.
Okay. Everybody got it? All right. Let's go a little faster. These, we're not going to go through all the effort to do the others. Find LN1. So all you're doing is putting LN1 on your calculator. Find the LN key. Put a 1 in. Close the parentheses. What do you get?
0.
Mm-hmm.
0.
Good. Number 9, log LOG10.
-1.
1.
1. Do you make somebody say -1? Should be 1. Number 10. Log base 4 of 4 squared. Okay. Somebody tell me the answer to this, and you can do it any way you want to. Exponential is probably the easiest, fastest way to do it.
I haven't grasped the exponential form yet.
You haven't?
Yeah,
No.
I'm still kicking that ball around too.
Yeah, because it's like,
Put an X over here and say 4 to the X equals the big log number. The big log number in this case is 4 squared. Can you look at it and tell me what the X is going to be?
2.
Uh-huh. Now, if you put this one in the math one, if you go down to math and put this in the math one, you'll have to put the 4 in the base, and then in the big log number, you'll have to put 4 squared, and then enter, and you'll get the 2. This whole thing counts as the big log number. And if you put it in changer base, you'll have to do log 4 squared divided by log 4.
okay, so the 4 to the X, that's where I'm getting confused.
4 to the X equals the big log number. It's the little number raised to the answer equals the big log number. The little base number raised to the answer, in our case it's X, our answer is X, equals the big log number. That's the way you change it from log to exponential.
If I go ahead and change that 4 squared to 16, I still get the 2. Will we always be able to do that, or should I get out of the habit of that?
Well, if you're going to use exponential, then you've got to get bases that are the same.
Gotcha.
But yes, if you
No,
change that to 16, you'll get it for sure because it's equivalent. All right, this is a challenge for you. This is going to take somebody that remembers some math on how to do this one. How do you do log base 3 of the 5th root of 3? Somebody try it and see if you can come up with a number. And then I'll tell you.
I got 1.9.
Nope. I'll tell you your answer. Your answer is 1/5. See if you can come up with it.
It's 0. I got 0.2.
0.2 is correct. Now, how do you
Yeah.
change that to 1/5?
Math and then fraction.
Math and fraction and enter, and it should give you 1/5.
Yeah, I know how I got it in my calculator. I just did the math, then scroll all the way down to A, and then I did the log, then I put the 3 in the little box. Then I did math again, and then I put 4 because that was the 3, what is it, the cube exponent, not
The
exponent,
fifth
but root, yeah.
Uh-huh.
But then all I did was replace the 3 and put a 5 there.
Yes.
And then I put the 3 obviously in the bracket, and then I hit enter.
Thank
Under
you.
math, there is a one that says, number 5 says the xth root of,
Yeah,
or you can do what she did and do the cube root of and replace the cube. But number 5 is the x root of, so you can do any x.
X. And see, I didn't recognize that until you said something. I just was like, I'm looking for something. I know I could, but yeah, that's how I got it.
All right, let me show you something that you're going to need to know down the road here. Let's do this as exponential. 3 to the x equals the 5th root of 3. To change from a radical form to an exponential, it's 3 to the, there's a 1 up there, exponent over index. This is called an index number. So 3 to the 1/5, that would be exponent over index number, is the way you change this from radical form to exponential form, 3 to the 1/5. So I would have 3 to the x equals 3 to the 1/5. Now the 3's are the same, so x is 1/5. Or you can do it in your calculator using that math, base 3, but you'll have to go back to math and put in the 5th root of 3 there, and you can get it. Or you can do the log 5th root of 3 divided by log 3. Somebody try that one and see if you can get the 0.2, which changes to the 1/5.
You do. That's the one that I tried.
Okay, and it worked?
Yes, ma'am.
Okay, good deal. All right, so let's try 12. 12 is log 10 to the -4. So all you have to do is put in log 10 to the -4.
But, okay.
See what you get. What'd you get?
-4.
That's -4. Now, think about that. The base is understood to be 10 if it's not written there. So this would be 10 to the x equals 10 to the -4. If you put that equal to x, so x would be -4. See how that works? If it's not written there, it's understood to be base 10. Look at 13. Let's do it some way. 256 is the base and 4 is your big log number. Somebody tell me what the answer is.
Four.
Yes. Everybody get it? Did you say 4? No, 4 is not right. Close.
Okay, hold on.
1/4.
I have a
1/4.
question. I have a
Should be
question.
1/4.
Okay, hold on.
Did you get 0.25?
Yeah, I got 2.5, but I just did like math and then the log, and I put 256 in the base, and in the parentheses I put 4, and then I just hit enter and it got 0.25.
And then you change your 0.25 to a fraction is 1/4.
So 1/4.
Okay, let's try this one. LOG base 16 of 1. Tell me what the answer is, somebody.
Zero.
Wonder how that one works exponentially. If we do 16 to the x equals 1, how can we do 1 as a base of 16? Well,
0.
that's right. So x is equal to 0. That's an important one to know right there.
I got a question for number
Yes.
12. Can we go back up? Okay, so I put it in. Did you say the log of 10,
Mm-hmm. Base 10.
base 10, and then you said 10 and the,
You can just do, you can type log. In fact, it's still on my calculator. It's understood to be base 10 if you put LOG. So you can just put in 10 to the -4 and it will give it to you.
okay, log, and you just said log 10. You don't have to do the 10.
The base. Mm-mm.
Yeah,
You
okay.
don't have to do the base if it's not anything there. It's understood to be base 10. So if it's not written there, that means it's base 10. So you can just put it directly into your calculator using the log, LOG.
And see, mine keeps saying errors. So like, I'm trying to figure out what am I
What
putting
you
in
put
here
in?
wrong. I did log, and then I'm doing 10, and then am I raising it to the
Negative.
-4?
Did you put the negative key down here at the bottom, or did you use this minus
Yes,
key? Use the
because I
negative
keep
key.
getting an error.
Do you have parentheses?
Did you close the parentheses?
Yes, yeah. Let me try it again.
LOG, and it opens the parentheses, put 10 caret -4. Bring your parentheses back down. I got -4. What'd you get?
Now I got -4, but I'm looking at me putting the same thing in, and it gave me an error at first, and now it's -4.
Oh, it changed its mind.
I don't know. Well, that's why I was like, what's going on? Okay,
I don't
-4.
know. All right, let's try 15. ln e to the 3rd. Tell me how you think you would do that one. Do you have an ln key?
LN and then E.
ln, and then second, and ln would give you the e. And then you just put the little 3 in there. Close it off and hit enter.
I got 3.
3? Good. All right, 16. The 7th root of E. Can you do that one? The 7th root of E. Remember that little thing about exponent over index rule. It might help you.
1/7?
Yes. How'd you do that?
Very quickly.
That converts to e to the 1/7 exponent over index.
Yeah, I don't know how to do that. I've figured out a trick, I guess.
What is your trick?
The
Share
trick
it.
is, it's hard to explain. When you write
Radical.
when you write a radical, the radical is n radical a, but that equals a n divided by 1. So the outside number is always going to be divided by 1, always. And the e just goes outside of the radical.
Mm-hmm.
And then there's another one for the logarithmic ones too that'll come in.
Yes. We haven't done those yet. but yes, there is. Okay, number 17, we're going to convert. Convert to log. And we get x 10 to the 5th equals to 100,000. That's true, but that's in exponential form. We want to move it to log form, which means we got to put a log here. So we got to know what the base is. What is our base? That's going to become this little number.
Is it 5?
No, that's an exponent.
Okay.
What's the base?
10.
10.
it
This
10
is
to
the
the second?
base. So the base is 10.
Is it 10 to the second? Wait, no.
Parentheses, 100,000.
Yes, this 100,000 becomes the big log number. And remember, logs are exponents. So the 5 comes over here, and that's your answer. It's an exponent. Okay, let's do it again. 25 to the 1/2 equals 5. So I'm going to write log. I got to figure out what my base is.
25.
25. What's the big log number?
5.
And what's my answer? The only thing that's left. This comes there, this goes there, this is the base. Okay, 19. Convert to log. E to the 5th equals P. Now it's E, so you want to use ln. ln where does the 5 go?
After the equals.
That's the answer. Where does this P go?
Has the big log number.
The big log number. And the E is your base, but if you don't put it, it's understood to be E because you wrote ln. So you don't have to put the E here. It's redundant to put the E there, although sometimes I do, just to keep me straight. Okay, 20, you have P to the W equals 125. See if you can do it before I do it. You've got to have log, L-O-G. What is your base?
P.
What's your big log number?
125.
And what's your answer?
W.
That's your exponent. 21, we're going to convert to exponential, so we're going the other way. They give us log to the 5th of 25, log base 25. Log base 5 of 25 equals 2. I'll get it right in a minute. Log base 5 of 25 equals 2. How do I write that as exponential? I think it's easier to go this way.
Five to the.
After the second equals 25?
Yes, ma'am.
All right, let's try this one. What's my base?
10.
If it's not written there, it's 10. 10
to the 1, Yeah, or -4 equals the 0, or will we need to put that in fraction ever?
No, not when you're converting. They want you to put it just like it's given. Okay. Let's try 23. Oops, wrong way. I almost gave you the answer. ln 40 equals 3.6889, and you're converting it to exponential. What's the understood base?
10.
What's it, if it's an ln, what's the understood base?
E.
E. E to the
3.6889.
equals,
40.
okay, one more and we'll quit for tonight. Log base m of v equals -y. This is the ones that they put on the ACT, like, or look like that. It's the base.
M.
M to the
-y.
equals
V.
All right, now I think you can do all of the others. Most all of them you can use the calculator for to do. You're just finding the ln and numbers. If you get an error, there's a number 27 you have to watch out for. It says use a calculator and find the log of -56. So let's do that on our calculator real quick. Log, log, parentheses, -56. What do you get when you hit enter?
Error.
Error.
Error. And what does the error say on it?
No real answer.
It's non-real. You can't have a negative long number. So that one is an error, and so the answer does not exist. So watch out for that 27. It's going to be like that. Okay, any questions? Okay.
Are we answering it like the no solution sign?
No, there's one of these little radio things there that says this one says 0, I think, and this one says the answer does not exist. When you hit that one.
Oh, okay.
Okay. You guys did well tonight. I appreciate you staying with me. I know it's after 8. I appreciate you doing this. Try to attend Thursday. We only have 4 days for attendance in this time. If you can make all 4 of those days, it would sure be super. If you could do that, that would give you 100% in the attendance for this time. So we only have 3 after tonight. So go forth and get this homework done, and you can do it any way you want to. You don't have to do it all 3 ways, just whatever way is easiest for you. Is there a question?
Okay.
No, ma'am. I'll see you Thursday.
Okay.
I got a question.
What is it?
This is about the calculator. Where was everybody getting the E from? Because every time I try to do like second and the alien button, it's giving me to the power of, and I don't know how to like get the E single.
Does it have an E down there when you do that? Do second and alien.
It does.
See that E down there?
But see, it puts a power.
It has an exponent up there, and you put in whatever number they give you. You put in whatever.
Yeah, but like one of them, number what number was that?
15.
Okay, so for instance, like number 16.
16. Okay.
16 said LN, and then it had the 7 inside the square root of E.
Right.
And I'm like,
That's a little tricky in your calculator. It's easier to put it in if you can convert it. Can you convert it from here? Can you change that to 1/7? Yes?
Yeah.
All right.
So instead of actually putting the E exponent in there, just convert it.
Yeah. Okay, let's do it. Let's do that one.
Okay.
That's going to be LN. Hit the LN key and then put in E. So that would be second in LN. That's going to give you E. And then it's going to give you that little exponent up there. Put in 1 divided by 7. And then close your parentheses and see if it gives you a big long number. So then you do math and fraction and enter, and it should change it to 1/7. See what I've got? LN parentheses E raised to the 1/7. I get this big long number, and then I change it to a fraction using the math key. Can you see that?
Okay, and then yeah, I see it. My last question on the last one we did, where we did log, and then N was the small number, V was the big number. N was the base number, V was the big number. How do you put in the equals Y, or do you not put the equals Y in there?
The Y, this Y down here comes down here. This is exponential form. This is log form. And when you convert from log